Welcome to the seventh module of LISP Your Mesh to Shape. In this module, we'll design ShapeM, a new AutoCAD command that will make possible an almost unlimited variety of shapes. We have studied how we can modify the Z value as a function of the X and Y values. But we should be able to do so also for the X or Y values. This way, we would have a really powerful mesh shaping command. Welcome to the new ShapeM command. The ShapeM command includes a command line user interface that will prompt the user for the necessary information. Once this information is input, it will call the endmod-xyz function, which is a variation of the endmod-z function we explained in Module 6. ShapeM begins by prompting for the mesh we want to shape up. Next, it will prompt for the shaping direction, offering X, Y, or Z as options. Once we have selected the shaping direction, it will prompt for the shaping equation function's name. This must be a function that has been already loaded. Here we are specifying the S02 function that is one of the shaping functions defined in our AU2012-mesh LISP code file. Finally, it will prompt for the shaping offset. This is the target distance between the maximum and minimum calculated values. This value will be used for scaling the transformation in the selected direction. The endmod-xyz function is the one that makes the vertex coordinates transformation. It will receive the four user-specified values as its arguments. Equation is entered as a string, so it must be transformed into a symbol applying the read function. As always, you can find the finer details for this function explained in the handout. The axis argument defines the transformation direction. According to its value, the variables I and j are set to point to the other two coordinates, and the 3D point coordinate lists are ordered. The offset argument is used to calculate a scale factor to be applied to the computed coordinate values. To calculate this scale factor, the values for all the vertices are computed in a mapcar expression. The minimum value is subtracted then from the maximum, and the offset argument value is divided by this height and is assigned to the scale-f variable. The value computed for each vertex will later be multiplied by this scale factor. Finally, the mesh entity definition list will be modified just as we did in endmod-z, and the entity is transformed in a call to endmod using the modified entity list as argument. The function concludes with a call to the entupd function that updates the transformed entity so the modifications are immediately displayed. As we said before, we have included in AU2012-mesh 10 functions that calculate a value as a function of two arguments I've called x and y, but which can obviously be any numerical value. They are named as S01 to S10. The screen captures shown are made from a flat square 5 drawing units wide mesh centered at the World Coordinate System's origin. This mesh has 400 faces in 20 columns and 20 rows. The offset value used to shape them was 3. I'll activate AutoCAD now to show a few examples of how these functions can be used to shape up our meshes. We'll begin with a flat square mesh. Initially, we will transform it in the Z direction. But these transformations can be superimposed. We will now apply a new transformation also in the Z direction. To which we can add another transformation yet in this same direction. Let's see now what happens when applying a different equation on the x direction. And another one yet in the y direction. Whatever you pleases you. This could go on and on forever. We'll show now how the mesh used in our title image was shaped using this command. We'll begin by making a 5 by 5 by 3 mesh box centered on the coordinate system's origin with 25 divisions on the x and y directions and 3 in the z direction. We'll then apply the S08 equation on the z direction with an offset value of 4. We'll have to smooth the mesh a bit, let's say to level 3. And that's it. This mesh is also used in the cover art for my latest book, AutoCAD Experts Visual Lisp, and it surely looks fine. This concludes our 7th module. Now we have a new AutoCAD command for shaping meshes in any way we can imagine and in others maybe beyond. Our next and final module will explore things that can be done with this shaped up meshes using some of the 3D object conversion and edition commands available in AutoCAD.